Hello everyone, my name is Ulrik and I'm a PhD student at the Department of Computer Science at the University of Oxford. I'm also a visiting fellow at the Oxford Center for Hindu Studies, and so in this video I'll say a bit about what the digital humanities might have to offer Hindu studies. Specifically, there's going to be 4 videos, and here in the first one I'll say a bit about the data science pipeline, like what workflows tend to look like in data science. Then in the next video, I'm going to say a bit about the basic tools that are available to do text mining. Then in the third video, I will get my hands a bit dirty and walk through a practical example of how to use a program called RStudio to analyze texts from the good register of electronic texts in the Indian languages, also known as GRETIL. And then finally, in the fourth video, I'm going to say a bit about how to use some of these tools in a way that is transparent and reproducible for yourself, for your colleagues, and hopefully for your future selves with something called R Markdown. So digital humanities is a fussy term. I will use it simply to refer to systematic use of digital and computational tools in the humanities. And I think there are 2 key aspects to that. The first is about digitization, so these processes of trying to make important text and materials available in digital form that you can store in databases that you then try to make searchable, and so on and so forth. In these videos, I'll focus on the second key aspect, which is that when we have our materials available in digital form, then there's a whole new realm that's unlocked, where we can do all sorts of new interesting analyses if we are able to adopt some tools from the data science toolbox. So for example, we can find interesting ways of visualizing information patterns in large amounts of text. Maybe we will want to automate certain kinds of analyses that would take way too long for us to do manually. And some of these tools are just really, really powerful supplements to the traditional toolkit that we might have available in the humanities for doing interpretive textual analyses and so on. Before we dive into the data science pipeline, let me just show you a quick example of what this could look like in practice from a paper that was published a couple of months ago. This is a paper in evolutionary anthropology, and just for way of context, in evolutionary anthropology, people have spent a lot of time pondering the following question. So you might ask yourself, how was it that humans were able to move from a world where we were running around in small hunter-gatherer bands, maybe in groups of 150 people, surrounded by close kin, close family, and so on, to a world where large societies were possible, where people were able to coordinate their activity in societies of tens of thousands, hundreds of thousands, millions of people? How did this happen? This is a bit of a puzzle because corporations tend to become more unstable if people are surrounded by others that they don't know and are not related to and are likely to never see again. What happened? How was this historical transition enabled? An answer that has become popular to this question in evolutionary anthropology is what was described by R Markdown recently in this book called Big Gods, and it is that religion was part of the secret sauce that made this possible. Specifically, beliefs and practices related to supernatural agents that would sort of monitor people all the time and would punish you if you did the wrong thing and reward you if you did the right thing and so on. Maybe that was part of the trick, like a culturally evolved thing that helped enable large societies. So make of that what you will. People have been talking about this for a long time, and a couple of months ago there was an addition to this debate that took a distinctly sort of data sciencey approach to this question, and that is the reason that I mention it. So the team behind this paper included some experts in Chinese history and religion, and they asked themselves, okay, so this sounds interesting. let's just systematically have a look at what functions are actually being ascribed to which kinds of supernatural agents in ancient and medieval Chinese texts. And can we try to enlist some of these new interesting data science methods to get at this question? So what they did was that they went to the Chinese Text Project, which is this open access digital library where you can go and read and download pre-modern Chinese texts online. And then they downloaded 96 important texts with a total of 5.7 million Chinese characters. So quite sizable corpus here, spanning a quite long historical period. Then what they did was something actually rather simple that they called co-location analysis in this paper, which was to simply ask, so how frequently do words or Chinese characters associated with the relevant type of content, such as punishment or reward, occur close to a word that's associated with a relevant type of agent, such as high gods or dead ancestors, and so on. So you can imagine coming up with the criteria for which Chinese characters you think are unambiguously associated with punishment, reward, high gods, deities, and so on and so forth. And then you can go start counting. Of course, you could try to get an intern to do this, or ask your sad graduate student to do it manually, but that would be silly. What you want to do instead is get your computer to do the counting for you, which you can when you have your text digitized. So what you see here is a key table from the paper where the column 10LR means that, for example, for a character related to punishment, they got the computer to look 10 characters to the left and 10 characters to the right, and then sort of just count how many times there was a character associated with high gods or deities and so on and so forth. The column 5LR means that they did the same thing again, but instead of asking their sad graduate student to now go and do it again, but differently, they just asked the computer to do it again, because computers love to do things multiple times, but then look only 5 characters to the left or 5 characters to the right. So the specific insights here doesn't really matter to our purposes, but they noted interestingly that emperors actually had significantly greater semantic association with categories of punishment, reward, and morality than high gods did, which for them was an interesting sort of exploratory addition to this debate. For our purposes, this is just an illustration of how you might start thinking about enlisting some of the tools from data science to help inform some of the research questions that we might already have in the humanities. Okay, so what does the data science pipeline look like? What would we have to do? How would we have to think in order to follow in the footsteps of this paper if you wanted to? This is what the world looks like to a data scientist. So one way or another, the pipeline begins with capturing data in a digital form. Obviously, if you're a data scientist at Facebook, you're in a more privileged position because you're working with data that already was digital. Whereas if you're in Hindu studies, it might more look like something like this, where you have all of these physical texts that you might want to take high resolution photos of, and then you will want to have the text in those transcribed in some way, maybe manually, or maybe you could find some clever way of automating it through optical character recognition software and so on and so forth. Either way, when you have captured your digital data, then you want to maintain it one way or another so that it isn't something that you're running around with on a USB stick that's can get overridden and so on. Often that means that we want to put it in a more secure database on some sort of secure server. Often people use something called SQL to think about and build the database. It stands for Structured Query Language. And we also often build databases in the form of what we call relational databases, which just mean that we will often try to find efficient ways of storing information so that we don't have to have sort of duplicate data. So imagine, that you might have one table that has information about all of the different texts you have, and then another table that have all of the actual content of the text and so on. So we often think about how we can partition out the information so that we don't have to store things duplicated, so that we can scale our databases very to a very large size and so on. So GRETIL that I mentioned earlier is an already existing example of an attempt to create a stable infrastructure for maintaining digitized text in Indian languages. The Muktaboda digital library is another example, and I'm sure there are others as well. In the rest of the pipeline, that's where programming languages such as R or Python comes in to the process, because we will then typically try to import relevant data from some of these databases, maybe often onto our own laptops. I use R for that, as we'll be going through in a couple of videos. Then when we have our data imported, that's just half the battle. Normally, we will then follow with a data cleaning process where, depending on how data was stored in the first instance and how you've read it into your laptop, then you might have to exclude certain information that's irrelevant to your purposes, such as maybe there was like a preamble in the text that's not really part of the text that you want to analyze. Maybe you'll find yourself with odd-looking characters that you'll want to exclude, and so on and so forth. So you might want to end up with something like this that you'll then want to go on and analyze. When you're done with your data cleaning, that is when the fun begins, because then we'll start the process of exploring and understanding our data. That normally begins with us having to transform our data in different ways. So, for example, maybe you want to do an analysis that requires you to split up your text into individual words. Then you might want to count those words and then find ways to visualize the result of that. So this, for example, this is a bar chart of the counts of words in text from the Muktaboda library. And we could visualize that information in different ways. Another typical way of visualizing this kind of information is through a word cloud, which is just a fancy and pretty looking way of showing more or less the same information, where instead of having a rectangular bar that's longer, if a word is more have a higher count, then you just give it a bigger font. You might also want to do some statistical modeling of your data if you want to have a more formal way of understanding and maybe predicting relationships internally in your data. At some point, you'll then want to communicate the results of what you've been doing, maybe in prettier plots that have a title and subtitles and so on. Or you might even want to build a dashboard that might even be interactive that you could put online for someone to look at in a way where they can sort of explore the data as well, where you could even make certain key parameters of your analysis available to the people you're trying to communicate with, so that they could not just sort of take your word for it, or not just see the aspects of your data that you were interested in them seeing, but where they can actually themselves try to dig into it without having to have a lot of specific knowledge about the software that you used to do the analysis in the first place. So that is what the data science pipeline looks like. In the next video, we're going to have a look at some of the specific tools that are available for doing text mining.